Do you guys have anything from story problems last time? We had those big ones that did the triples. Did, excuse me, did having your graphing calculator help you with those? A whole lot, I would imagine. Once you got the idea of, excuse me, of how to put them in your calculator, I'm sure you were good to go at that point. So was there any we need to go over? I know I had a couple of you send me some stuff, but I think I may have answered it for you, I hope, with what your questions were. So, so maybe we don't. I don't know. Next time on Monday, we do have your test that is over Chapter 8. Okay, so we are going to finish that up and so forth, and I'll tell you what you got to do to get ready for that on Monday. We skipped section 8.7. So we do not do that. It was basically the same stuff we were doing. It's a different method for solving them, and it just gets a little confusing if we left it in there. So, excuse me. So we removed 8.7. So 8.8 is the next one, and that you're going to need your graphing calculators for too, because we are going to graph inequalities with these. And inequalities, of course, means that we're going to have a variety of answers, because it's not going to do just one point where the two cross, but it's going to be a combination of different pieces that go with it. So the first thing, of course, is our objective, and that's to solve linear inequalities graphically. So we're going to get rid of that sheet and move on to what we need to do. So to solve these, first, we said that for each inequality, the graph is a boundary line, and the shaded appropriate half plane refers to the section in 4.6. So in 4.6, we had a section in that point that was letting us graph these, and so we ended up graphing them and coming up with what their solutions were. If you have a greater than or equal to, or a less than or equal to, this will be a solid line, because the equal to means that this line that we graph will be included in our answer. If you have a greater than and a less than with no equals, the line is dashed. And we'll, of course, talk about that more when we get there. So our line is going to be dashed at that point. And so we will end up having it be dotted lines. And when we work with the Hawk stuff, and I'll bring that up after we go through all the lecture piece, and show you in Hawks what you need to do with that, this at least tells us what kind of line we end up having to have. A dashed line means the line's not included. So if you had something that fell on that line, you cannot use it for an answer, because it would end up making the statement equal, and we can't have an equals happening with that. So next, 2, determine the region of the graph that is common to both half planes, the region where the shading overlaps. So when we do shading, what that means is that if we have a graph and we have a line, and that line is coming through, so this means that I've had an equals within my problem. So that means that I had if I had a greater than or equal to, what it would do, if it's a greater than, we shade above the line. So we're going to shade above the line. So that means that if I had this greater than, this is of course not a particular line, I will shade above the line. So if it's a greater than or equal to, or just a greater than, we're going to shade above the line. If it's a less than, I'll put the same line in here. If it is a less than, so a less than or equal to, or just a plain old less than, you're going to shade below the line. Yes, you can. You're still going to need to do a test point. So you can do it that way too. You could do either one. The question was, do we do a test point? And I'll show you that in a second when we get around to doing a regular graphing. But it works both ways. So if you can keep these things in line, you know where you're shading. But if you want to do a test point, you can do a test point, because a test point will show you where that shading is at. So less than, shade below the line with those. This region is called the intersection of the two half planes and is the solution set to the system. So what would happen, I shade below my line in this case, so you see what happens with that. And so what you're going to see when you graph one of these is one line will come like so, and you may shade above the line on that one. Another line may come in like so, and you shade below the line on this one. So your solution is going to be in that region where the two lines are going to cross. So back in 4.6, we did one graph, one line, one single line, and shaded it. In this case, we're going to shade two lines on top of each other, and we're going to figure out where our double shading is at. And within the Hawks program, it'll show you where that double shading happens to be, and you just need to pick a letter that's connected with it. But we'll get to that in a minute, of what ones are there. Okay? So then, if we continue with this piece, to solve the two linear inequalities, to check, pick one test point at the intersection and verify that satisfies both equations. So if I had my graph that we just had on the opposite side here, the line coming in like so, and the other line going down like so, and we said this was where the double shading was at, I would pick a test point and a location in there and plug it into both equations and make sure it works. And we'll, again, get into that in a minute here, too. Because, again, this is just kind of laying out what we're going to do with these. So if there's no intersection, the system has no solutions. So a no solution might be where you have a line like this, and you have another line like this, and there is nothing that is overlapping in shading. So your piece that between the two lines has nothing in common. So that's what this is referring to, is that there is no solution to this one. So this opening will still stay open. So there is no solution to that point. So you want to keep that in mind when you do these. So let's look at one. And let's go through and see if we can do the graphing on this one. And so what I have there is, of course, two equations. And with those two equations, I need to be able to graph those. So to graph them, I need to take each equation and get it so it's set equal to y. So when I do that, if I take 2x plus y is less than 4, I move my 2x over. So I end up with y is less than a negative 2x plus 4. Now, when we graphed before at the beginning of the chapter, if you solved it in this format and you put it into Hawks, it automatically put it on your graph and ended up graphing it. So we got to go a little bit further here and show you what's going to end up taking place with this. So if I go through and I set up my lines, so I set up brand spanking new pen and it's dry. Well, I guess we're going to see if the green one works. Hopefully the green one works. There we go. So we set up our line, or our Cartesian coordinate system. And so that's our coordinate system. This is my x-axis, and this is the y-axis. And so what we end up having with this, if I'm going to graph it, this is my intercept. So that means my graph is crossing at 4, 0, 4. So when I'm at 0, I'm up at 4. My slope is negative 2 over 1. So that means in order to graph it, I'm going to go down 2 and over 1. And if I connect these two, because I have no equals in here, my line is going to be dashed. So I'm going to go through and I'm going to dash this line that goes through here. Then, because it is considered to be a less than, I'm going to shade. This part is above the line. This part is below the line. I would shade below the line. The test point comes in of 0, 0. And because 0, 0 is on this side of the graph, if it works, if this came out to be true, then I would know that that is the side that I shade. If I did a test point over here, such as if I tested the point of 1, 2, 3, up 2, and I plug that one in, it would not work. So if I put 0, 0 in here, 0, negative 2 times 0 is 0. 0 plus 4 is 4. So 0 is less than 4. So because my test point is true, I shade that side. If I tested it with this point of 3, 2, I would put 2 in for y, negative 2 times 3, plus 4. I would find out that 2, negative 2 times 3 is a negative 6. Negative 6 plus 4 is still leaves me with a negative 2. This comes out to be false. So I would not shade where that point's at. Okay, so that's what test points are about. So if I tested this one and it worked, that's where I would shade. So you don't have to test 2 points. I just wanted to show you what would happen with that. So then if we go and we look at the next equation, we've got this one all figured out, so we're going to leave it sit there. Then we're going to go to the next equation, which is 2x minus y is less than or equal to 0. If I subtract 2x from both sides, I get a negative y is less than or equal to negative 2x plus 0. When I divide by a negative 1, every piece, I get y. But because I've divided by the negative, my inequality needs to switch. And that's probably been a while since you guys had known that that needed to switch. But we need to switch it in there so that it comes out correct. So negative 2 divided by negative 1 is 2x. 0 divided by a negative 1 is still 0. So what does that tell me about this graph? Well, it tells me my intercept is 0. Too bad my red pen doesn't want to work. My intercept is 0. Then my slope is up to So I'm going to go up 2 and over 1. Am I off the screen? There we go. That's better. So I'm going to go up 2 and over 1. And because my inequality had an equals, that means I am going to go through and put a solid line in here. Make it dark enough. Then with that solid line, I need to find out what side gets shaded. I can't use 0, 0 as a test point with this one because it's on the line. It's on the graph because it goes right straight through that spot. So I need to pick another test point. Your second test point that works really well is 1, 1 because it's real easy to work with 1s in there. So if I plug it in here, I'm going to have 1 is greater than or equal to 2 times 1 plus 0. And what do I find? 1 is not greater than 2, so I do not want to shade where 1, 1 is at. Okay, so I would not shade there. But also, because it was a greater than, it would have told me to shade above the line anyway. So if I shade above the line, I'm good to go. Now, where is my answer? Well, my answer is where both sides are shaded. So you will see this when you do your problems in Hawks. It will show you that double-sided side to that. And what they will do is they will label these. They will say this is A, this is B, and this is C, and you would pick your answer to be where B is at. And again, we'll go through those. No, no, your exact answer is all of these points. Anything that's in this box or in this area is an answer, okay? So it will never say, what's an answer to your equation, all right? If you want to make sure that you pick this right spot, you can end up taking a test point that's in that area and see if it works in both equations. So if I picked -2, 0, I would put a -2 in for x and 0 in for y and see if it works. So -2 times 2 is a -4, plus 0 is 0, and sure enough, a -4 is less than 4. We all agree? If I plug it in the second one, -2 times 2 is a -4, minus 0 is still a -4, is less than or equal to 0. So I'm still good. So I know this is where my answer would be. If you tested someone in somewhere out here in the single shades, it will make one true, but the other one will be false. Okay? So for instance, if I tested 1, 0, and 1, 0, and put 1 in here and 0 in there, I get 2 is less than 4, which is right. But if I put it in here, 1, and I put 0 in, I have 2 is not less than or equal to 0, so therefore it doesn't work. It worked for the first one because that's where the first line is shaded, but it would not work for the second one. Okay, so does that make sense? Hopefully. Okay, we're going to do some more of these so that we can get a good idea of what is taking place. This is one that is worked out in the stuff here. Get that ladybug out of there. And it has a special part in there. It says graph the points to satisfy the system of inequalities. If you look at this equation, the x is less than or equal to 2. That equation graphs as a special line. It has no y in there, notice? So anytime that you have an x equal to 3, an x is less than or equal to 4, or x is greater than or equal to 2, the shape of this line is always going to be a vertical line. So this will yield a vertical line. Always. At whatever the number is. So in this case, it's going to be a vertical line at 3. In this case, it's going to be a vertical line at 4. And in this case, a vertical line at 2. So this one that we had in here is a vertical line at 2, so it's going to go straight up and down. This one's slanted because it has a y in it. And it's going to end up being the one that slants. So we end up going through and, of course, graphing these. And the graph that comes out looks like so. So we have a vertical line. This is what x is less than or equal to 2. This line, in this case, I'm going to graph, and if I use my slope-intercept, and this graph happened to have been y is greater than or equal to a negative x plus 1. If I graph the red line, I'm going to go up at 1. My slope says go down 1 and over 1, and so that would give me my graph that's in there. And so because it's a greater than, I can check a test point, 0, 0. Does 0, I guess they use the test point of 0, 3 for theirs, and whether it worked. And so we end up plugging that part in because they're doing a test for the double shaded. I don't know if you can see the light blue. You see light blue in there? It shows very light up here, so I don't know whether you guys see it. And then the double shading makes purple because you have the pink that's in there that's connected with those. Okay? But if you have that type of a line, that's what you're going to end up with. The other special line that can fit into this is a blank sheet of paper here. So the other special line is a y equals 4, or a y is less than 3, or a y is greater than or equal to 2. These are specials because these graph horizontal lines. So you get a horizontal line at the number. So if we had our graph in here, the very first one would be up at 4, and you would graph a horizontal line in there. Okay? If you graph the second one, you would be up at 3, and you would have a dotted line going through that one because there is no equals. And then finally the bottom one is at 2, and that one I would end up graphing it at 2 with a solid line because the equals can be included. Now if I want to do my shading, again my test point, 0, 0. But if I test this, I can only plug the y value in. I cannot plug the x value in for my test point because I have no x. So 0 is less than 3, so I'm going to shade where 0, 0 is at. This one, if I use my test point of 0, 0, 0 is not greater than or equal to 2, so I would not want to shade where 0, 0 is at. So you get these test points, so you get this idea that if it's, again, less than, I shaded below the line. If it were greater than, I shaded above the line. So if you use those two things, you're underway with those and getting those to graph. So I wanted to make sure I put that special line in there as well with that one. So we'll get that out of the way. Here's another one. Let's see if we can graph this one and see what happens with it. So if we go through, and in order to graph it, of course, I need my x and y intercepts. And again, when you do this by hand, of course, you'd probably want your graph paper to end up using that. But so we would solve for y. So when I do that, move my 2x over, and I find y is less than, whoops, oh, sorry about that. Y is less than or equal to a negative 2x plus 6. So we have questions on graphing these. I know some of you may not have graphed in quite a while. I think 4.3 kind of did a good review of some of that, where you had your slope and you had your intercept, and we could graph it that way. And so in here it says I'm going to go up 6 because my intercept is 6. My slope is negative 2 over 1. So I want to go down 2 and over 1. And so I find that, and it ends up being this for my graph within this one. And so it's got an equals. So that means I want a solid line. So if I get a solid line in there, I am good to go with that one. Then I need to go and figure out what side's shaded. So what side would you guys shade? So if we're going to shade it, what would get shaded? Shade below the line? Mm-hmm. Yep. And if you used your test point to do that, and use 0, 0, you would have 0 is less than or equal to a negative 2 times 0 is 0, plus 6 is 6, and that's true. So I would shade where my 0, 0 happens to be. Okay, so we're good there. Second line, move my x over. So I end up on the second line with y is less than a negative x plus 4. And I don't think this red pen has decided. Oh, it's getting a little better. Maybe it was just the tip of it. So we'll try it. It says to go up 4. And then the slope. No, it's still not going to do it. The slope is a negative 1 over 1, which means from 4 go down 1 and over 1. And I would end up getting a graph, but because it has no equals, my line is dashed. So I get a dashed line out of that one. And what side of it gets shaded? So test point 0, 0 is not on it, so I can still use it. So 0 is less than a negative 1 times 0 is 0 plus 4. True statement 2. So the side that's shaded on this line is there. So my answer for this one is where the double shading is at. So my answer is right in here. So anything in that area will make this a true statement. So I can use any of those points that happen to be in there. Okay, questions with that one? Anything of what we did with it? So it's just putting 2 on top of each other so that we end up getting our pieces in there to come up with those. Okay, all right. This one, reason this one was, of course, that I put it in here was because x is greater than or equal to x. That means when you have that situation, that when you graph this one, you are going to have the same point for x is going to be the same value for y. So my intercept is going to be a plus 0 at the end. It's going to go through there. If there's no number at the tail end, there is a 0 there. Slope says go up 1 and over 1. And if you want, if you're doing this on paper, you can go up 1 and over 1 as many times as you'd like. And then you would draw in your line. Since it's got an equals, it's solid. The bottom one, intercept is 2. Slope says down 1, excuse me, down 1 and over 1. Has an equals, oh, not down 1, up 1 and over 1, sorry. It has an equals as well, but I've just got to get my shading in. So if I shade the top one, I'm going to shade above the line. Get my shading in here. Can't use test point of 0, 0, so I want to use, I can't use 1, 1, so I'm going to use 2, 1. And so 2 is not greater than 1 for y, so I know I can't shade the bottom part. So now if I go on finish this other one, I'm up at 2. So I go up 1 and over 1. It is also a solid line. And it's going to shade below the line. So the answer that works for this one is a stretch in between the two. So it's just this little narrow section that's in between them. Okay? With that one. All right. Questions with these? And that's again by hand. But you also can stick these on your graphing calculator. So everybody grab their graphing calculator so we can see how that ends up working. And your graphing calculator has a way of shading stuff. So we can shade things inside of it. And so if we take a look at that, and I may have to switch my lights over here because it's not showing up at all. I think it was if I put it on, did that show the, yeah, that kind of shows the, I get it in the right spot up here. Okay, let me get it where we can see what's going on up here with the graphing calculator. First off, in order to put these in, just like we did before, we need to solve for y in each case. So if I solve the first one for y, I'm going to have y is less than, move my 2x over, so minus 2x plus 4. So we're going to go to y equals. So everybody get there on their calculator? You might not have a calculator, it needs to borrow one. Are we doing good? You need one? Okay. So go to y equals, and if you've got something in there, So let's say you got something that's in that spot. Just hit your clear button, and it will wipe out. And if you've got another one, go down arrow, hit clear, and get everything wiped out of there. So we don't have anything that's left in our y equals. So then we're going to put in a negative, and use your negative. Don't use your subtraction sign. Negative 2x plus 4. And if we want to know what its graph is going to look like, arrow back over. Use your over arrows that are right here and over arrow back to get in front of your y1. Right in front of it, all the way to the front of it. Okay? All the way to the front of it is where you need to go with that part. So if I go all the way to the front, and if you keep hitting enter, what's going to happen with that is it's going to keep changing. Yes? It's kind of fuzzy back there. No. So move up front if you want. All the way in front of y1. So if you're way over here, if you're way over there, you want to move your arrow all the way back over to the front part of there, okay? Now, in front of there, there are, I think it's like 5 different things that can happen in there. If you hit enter, it will change your line and make your line fat, just once. If you hit enter a second time, it gives you a box that bounces back and forth, and that box that's bouncing back and forth that's in your calculator has a line kind of drawn through it, and this top part shaded. That is considered above the line. So if it's above the line, this means you will click on that and make sure that it's facing the y if you want a greater than or a greater than or equal to. Okay? So that's what that means. If it's bouncing back and forth and you see that shaded up above, that means I'm shading greater than or equal to. Okay? If I hit enter one more time, that box changes, and then the box goes to having shading below the line. That's why we talked about above the line and below the line, because this means I have a less than, or I have a less than or equals to that's taking place in there. So less than or equal to, or a greater than and greater than or equal to is the 2 pieces in there. Since my graph has a less than, I'm going to leave it there. So all I need to do now is over arrow again with my arrows right here and get back on top of the equation. So now, whoops, are we there? Oh, back arrow. And if you hit graph, you will see the shading that goes with that line. Okay? Now, the only thing we cannot do on our graphing calculators is we cannot determine if the line is dashed or solid. It'll only let me put one type of thing in there. It won't let me put dashed lines and solid lines. So you need to remember that this is dashed because there is no equals. And it will ask you that in Hawks of whether it's dashed or whether it is a solid line that's in there. Okay, so that's one. Yes? It won't let you, on your calculator, it won't let you do both. It won't let you shade, and it won't let you set up the line as being dashed. It'll only let you set up the line as being, as shading it. And shading is more important than the dashed and the solid. Okay? So now go back to y equals. We've got 1 in here. Go back to y equals. Go down to y2. So y2, I need to solve this equation. So if I solve it, I'm going to move 2x over. So I get a negative y is less than or equal to a negative 2x plus 0. Divide by negative 1. And I find y, I have to invert my inequality. And a negative 2 divided by negative 1 is 2. 0 divided by negative 1 is still 0. So if I put this into my equation, I'm just simply going to put 2x. Do I need the plus 0? What do you guys think? That's right. We don't need it. You can put it in there. Is it going to change anything? No. But you can leave it off. Now go back with your back arrows in front of your y equals again. And we are going to tell it I want a greater than. So I'm going to hit enter once, enter twice, and now see how it's shaded above the line? That's what I want. So I want to go back with my back arrow, back over my 2x. Now when I hit graph, I'm going to have the first one, but I'm also going to have the second one showing up in there. Some of the new graphing calculators have 2 colors, so you get to see different colors with your line. So that's kind of nice. Change your who? Yeah, it might be your window. Well, let's see. Second quit. Y equals. Oh, up above, when that happens, the error that you were coming up with is, then let me go back to my y equals, is up above. If you have one of these stats plot things turned on, it's going to give you, when you go and hit graph, the first one's coming in, but the second one, and mine didn't give me an error for some crazy reason. But you want to go up here and make sure the stats plot's turned off. So hit enter on top of it if it's on, and then go back down below. Okay. Another error that can come up is when your window is set kind of weird. So you can go to zoom and go to standard of 6, and then it will standardize it too. Did that take care of your issues? Okay. Because sometimes within your calculator you get these extra keys that are hit that don't always end up giving you what you want. And again, trying to show you what's in there. Let me go play with the lights again so we can get it to do something a little bit different here. Oh, does that make the calculator show up better or not? Well, maybe a little bit better. I don't know. If I move it over. Yep, that made it worse. A little bit better over there. But you can see where the double shading happens to be on your calculator. And so what is showing up on your graphing calculator is this shows up in your keys, and this is what's showing up on your screen. So if you displayed your graph, this is what's showing up. So your area where this double shading is at in here is the piece that's your answer. Okay? Within your Hawks homework assignments, and we're going to go there in a second, it's going to show you, it'll give you a letter in here. It'll say this is A, this is B, and this is C. And it'll say pick the correct answer. And the correct answer is where the double shading is at, so you would select B. So B would be your answer for that one. And so you get your double shading. Do we do another one with the shading in your calculator? What do you guys think? Maybe one more. There's some extra ones in here. So let's take a look at the very first one here and see if we can get it to show up on your graphing calculator. So it's all set up for you already. So now let's go to our y equals. Clear out what we've got because we don't need those anymore. Go back up above. Put in your first one, y, and we're going to put in a -3. Since it is a less than, go back in front of y, and I want to shade below the line. So that's the one I want. Go back across, hit graph, and it will show you your graph. So this graph is only showing that it's graphing below the line, and you've got one line that happens to be at the bottom part of that. And so then if I put the second one in, go back to my y equals, go down to 2, put in x -3, go over in front of it, and which one do I want to select now? So I would want to select the above the line. So I want to hit my equals till I get above, or my enter until I get above the line. And so I'm set with that one too. Hit my graph button. And it shows me my shading. And what did it show me this time? Well, the shading on this one is that it's got some double shading right in here. And again, it's probably hard to see back in if you're not looking at your own calculator. Now, it shades up and down for one graph, and it shades crosswise for the other. So you get a checkerboard if you don't have color in your graphing calculator. The newer ones have different colors, so your graph will show up in whatever color it happens to be in. And so you have that. Now, what would you say about each line? Well, I would say this one is solid, and this also is solid because there's an equals in there. If we look at the next example that's here, I can graph this on my graphing calculator. I can graph the y is greater than 2, but I cannot graph x is greater than 2. Be aware of that. This one doesn't show up on your graphing calculator because I can't graph x's. Okay, I can graph y's, what y equals, because all of my y equals parts is all y equals something. There is no x in there. So you have to remember that this is vertical. So on your calculator, you can do the y at 2. I'm going to clear out what I have. And then I'm going to go back and put 2 in there. Go across. Oops. And put in a greater than. And so I can take a look and see what that looks like. So that one's coming in like so. But to do the bottom piece in here, I have to go through and manually graph that part. So y is at 2, and it should have been a dash line. And it's shaded above. But x is at 2. I have to physically stick that one in place. And what side gets shaded? So if I shade this part, the shaded piece is going to be below the line, or if I put 0 in, 0 is less than 2, so I want to shade this side. So my answer is right in here. So that's the location of what my answer would be. So just be aware that when you've got x's involved, you can't always graph those. Questions of doing this? You think we're pretty good? Yes? Okay, it's not showing the whole graph. It might be a Windows situation.
That last problem.
Yeah, your Windows isn't adjusted right. So you go to Zoom, go down to 6, and it will standardize your graph, and then you'll see it.
Okay.
Okay?
Yeah, thank
Yep.
you.
Yep, you're welcome. If you are not getting a graph to show up on your graphing calculator, it may mean that this Windows button right here, the Windows, if you had changed anything in here, and it's a good idea to put this in there because if somebody is watching this from my online class, if you put 2 in here, and let's say you had -5 in there, and you hit your graph, and your graph's going to look funky because that kind of looks like a really strange looking graph. It doesn't even look like I don't even have my X and Y axis in there. If you go to Zoom, down to 6, then it will change your window back. Okay, so then your window will come back and you'll be able to see what your graph looks like. So do that and watch your changes in there. Okay, this one I'll put the answer. The answer is actually on the back here of what each one of these looks like. So this is number 3. So if you are watching this, graph it and then see if your graph on your graphing calculator matches what we happen to have there for that answer. All right, right now I'd like to go to your Hawks assignments because they are a little bit different for what you have to do with this whole thing. And so let's take a look at what happens with practice. when we do these, because they are just a little bit different. So we're going to walk through some here that are in your practice section so you have an idea of what to do with those. So first off, you look at your graph up here. In your graph, it says y is less than 6. So what kind of line would that be? Has no x's, so it's a horizontal line. Is it solid or is it dashed? Dashed, so you click on dashed, okay? Then it says down here, enter 2 points. Well, if you are, when we did these, we paid attention to our slopes and our intercepts when we graph things, but in this case, everything is going to be up here at 6. So every point, y is going to be 6. So the number at the beginning can be basically anything you want to put in there. And the second point, the y is going to be 6 because it's going to give me a flat line. So I could put a -2 in there. And it's going to graph it for me. Notice how it put it in there? And it put the shade, or put the shape in there. Now I need to determine what side is shaded. So if I put 0 in there, is 0 less than 6? What would you guys say? 0 less than 6? Yeah, 0 is less than 6. So it gives me a region, region A or region B. So I'm going to graph it in region B. And I'm going to hit submit my answer. So that is the first line. So we did great there. Then we're going to look at the second equation. It says graph the solution set for the second linear equation. And is it dashed or solid? Solid. A point, because it's a flat line at a -2, that means every y is going to be a -2. Every x can be whatever it wants to be. But my y is always going to be a -2. So I want to put that one in there. And what side's going to get shaded now? I want greater than, so test 0, 0. Is 0 greater than a -2? What would we say? Yes. So that means I'm going to shade where 0, 0 is at, so I'm going to pick C. Submit my answer. And I did it right. And then it's going to put both graphs on top of each other. I don't know how many people have missed an answer because they didn't pay attention to the double shaded colors. And I don't know if you have any, color blindness at all. It might be hard to figure out where that shading is at. But the double shading, of course, is in between. So we would end up picking the answer of C because that's where the double shading is at, and then submit your answer. So each one of these is going to have 4 steps to it. So first step is to make sure you graph your line, or 3 steps, I guess I should say. Graph your line, pick out your shaded part, then go through and graph the second line, and so forth with those. But you need to know a little bit about graphing because it doesn't just automatically put your point in there. So keep in mind of what you have. So if we looked at this one, x is greater than a -5. Solid line or dashed? Dashed, yes. And because x is greater than a -5, we know that is a vertical line at a -5. So that means every x is a -5. And every y can be whatever it wants to be. Oops, I put the same number, I guess. And then I need to decide what side shaded. So 0, 0 if you want your test point, or because it is greater than, I'd shade above the line, in other words. So I would pick A. But if you pick your test point 0, 0, 0 is greater than a -5, so we know we're going to shade A. And then do the bottom one. So it is a solid. Oops, I got to go to next, I guess. It's a solid line because there isn't equals. It is a horizontal line at a -2, so that means every point y will be a -2. And then you can pick whatever you want for the first part. And as long as you pick within your range that you happen to have. And what side gets shaded? So 0, 0 is here. Is 0 greater than or equal to a -2 if you check it? 0 is greater than or equal to a -2. Is that true or false? True. So I shade where 0, 0 is at. So I shade C and submit my answer. And then it's going to put them on top of each other. So what would be my answer? So my answer will be the purple part, or D. Okay. I want to get to one that's got different pieces. We did the one like that, so we're going to skip it. We did one like that, we're going to skip it. This one, you need to solve for y before you can do anything with it. Okay. So dashed or solid? Dashed. That's the easy part. So then we need to go back and pick some points. So let me put that on my paper over here. So 2y minus 4x is less than or greater than 16. And let me switch back to my ladybug here where we can solve it. And so if I solve it, I need to move my 4x over. So I get 2y is greater than 4x plus 16, divide by 2. So I find y is greater than or equal to 2x plus 8. Now you have a point in here. Your point is always your intercept. So that last number, once you solve for y, is your y-intercept. And the y-intercept is 0, 8. So that can be one of my points that I pick. When I go back to Hawks, it can be a point that I take a look at. The other thing that I know about this is my slope. And my slope is 2 over 1. So if I go back to Hawks now, and within Hawks, if I want to graph my points in here, I can put in 0, 8. And it will put my point in there. Notice how it put that point in my graph? So then what that means is I can use my slope now and go up 2 and over 1 and get an additional point. So that additional point that I just found is 110. And so I have my line graphed, all right? So if you use your intercept and your slope, you will find an additional point on every one of these. So my intercept is always that last number in my equation. My slope is always what's in front of x. Slope, in this case, I'd go up 2 and over 1. So I get that graph. Where am I going to shade? Do I shade side A? Do I shade side B? So it says greater than when we got done solving it. So I want to shade probably where B is at. Or test with 0, 0. Y, 2 times 0 is 0. Minus 4 times 0 is 0. So 0 minus 0 is still 0. So 0 is not greater than 16, so it's false. So I want to shade where 0, 0 is not. So I want to put B in place and submit my answer. And then I'm to the second line. It's dashed. It's a y is greater than a -2. Whoops. Up if I get my thing in there. So it's dashed also. And a point, because y is is greater than a -2, I know my y part is always going to be a -2, and I can put whatever number I want in here. And then I need to decide what side gets shaded. It's greater than, so I'm going to shade above the line, or C, or put 0 in. 0 is greater than a -2, so that's true, and submit my answer and go to next. And again, pick the shaded, so C, and submit your answer. So what do you guys think? Think we're okay or not okay? Okay, this one here with the X in there, you got to do that piece, but make sure you solve this one for Y because it will give you your numbers in there if you need to find points in there. You can also plug in values to get your points, but it's just easier to use your slope and your intercept if you can get into doing that to find your points. So let's see what the next, let's see if they give us anything different, which they're basically, they come out all basically the same. Again, solve for Y if you looked at this one. For each one, and then graph them, of course. We good? Okay. As long as we're good and what we got going, we've reached the last one in here, and so, of course, we didn't solve all of them. That's why my thing is empty, but I think we're okay. Any last minute questions on the graphing piece? Okay. So what you need to do for the upcoming test is, of course, you always have that chance of getting your 5 extra credit points, and some of you didn't take advantage of it last time. And I think what I kind of noticed was that when you didn't take advantage of doing the practice test, it hurt your regular test. So make sure you get in and do a practice test. So you do a practice test over 8. Again, create your own questions. We all good at knowing how to do that? This time, we'll make it 35 as usual. It's going to be more questions than what's on your test, actually. So it'll give you a good practice with it. And then if you have all of your homework assignments completed, that's the additional 4 points. So make sure you do that. That's 9 points. So that means you can miss maybe up to 3 questions on your regular test and still have a really good grade. Okay, so do it. I know you look at it and say, oh, it's just such an amount of time I'm putting into it. But it really helps. It helps, it helps, it helps. Okay? And if you have blank assignments that you haven't completed, they're going to hurt too because that stuff's going to be on your test. So make sure you get all of your homework stuff done for that. Okay, so I'm going to stop this recording and